Dear students, today we'll continue our practices on mathematical analysis 1. So today's topic is critical points and extrema of function. Firstly, let's give a definition to a critical point. What is critical point? We say that the point x is c is a critical point of the function f of x if f of c exists and if either of the following are true. So, derivative of f at the point c is 0, or the derivative of f at the point c doesn't exist. If these two conditions are whole, we can say either of these two conditions, of course. We can say that the point x is equal to c is a critical point of the function. Note that we require that f of c exists in order for x is equal to c to actually be a critical point. This is an important and often overlooked point. What this is really saying is that all critical points must be in the domain of the function. If it's not in the domain of the function, then it's not a critical point of our function. So it should be in the domain of our function. Belongs to our domain. And now, let's consider the first example. Determine all the critical points for the function f of x is 6x fifth degree plus 33x fourth minus 30x cubed plus 100. So we need to find the all critical points of this function. And recall the definition. We need to find firstly what the derivative of this function, and derivative of this polynomial is 30x fourth, this one, yeah, plus 132x cubed minus 90x squared. And we can factorize this polynomial, take out this 6x squared out of the brackets, and we have inside of brackets 5x squared minus 22x minus 15. And now we can say, we can factorize again this bracket, and we have the following one: 6x squared 5x minus 3 times x plus 5. And now, what should we do? If we consider our definition, we need to equating 0 this derivative, yeah? So, and in this case, we have 6x squared is 0, the first one. The next one is 5x minus 3 is 0. And the next one is x plus 5 is 0. So we have how many critical points? In our case, 3 critical points. The first one is 0 here, and we have 3.5, this one, and minus 5. So we have 3 critical points of this function. Now, example number 2. Determine all the critical points for the function g of t. So we can see here we have cubic root of t squared times 2t minus 1. For this function, we need to find all critical points. So to write more comfortable for us, we can write in this case, so t in the rational power, yeah, 2 over 2t minus 1, or if we multiply to the brackets, we get this one. So here we have this one, and now we can work with this one with instead of our function. So let's find the derivative of this function again. So g of t is now derivative of g of t is now this one. So here we have 10 over 3 t t, and this is minus 1, 2 over 3 we have, and 2 over 3t, the power of minus 1 over 3. And if we simplify the expression, we get the following one. So now we can give the common denominator here. Look here. So if we multiply 10t 2 over third to 3, and yeah, we don't need multiply by 3, we need multiply by just t 1 over third, and we get here 10t just, yeah. So because it will be 1. So now we have 10t minus 2 over 3t 1 over third. And now it is if we equating this 1 to 0, it means we need to equate our numerator firstly. 10t minus 2, it is 0, and we have t is 1 over 5. This is first critical point. And now we have the next one where the derivative does not exist. It is t is 0 because it is in denominator, and the denominator shouldn't be equal to 0, not equal to 0. So it means t is, if t is 0, the derivative of our function g prime of t not exist, doesn't exist. So it means it's also critical point of our function. So we have two critical points. The first one is t is 0, and the next one is t is 1 over 5. And now, example number 3. Again, determine the critical points of g of function w. So here we have 2w cubed minus 7w squared minus 3w minus 2. And the first step is again to find the derivative of this function. And if we find the derivative of this function, we get this function. So it is derivative of our given function, because here we have 2w cubed, it will be 6w squared minus 40w and minus 3. And now, again, one more time, equating to 0, and we get the next one. So it will be 6v squared minus 40w minus 3 is equal to 0. And if we solve our quadratic equation, we have here two roots. So because the discriminant of this quadratic equation is 40 squared plus 4 times 6 times 3. So it's greater than 0, and we have two real roots of this equation, and they are this one. So 7 plus minus square root of 67 over 6. So we have two critical points of this function. So the answer is 7 plus square root of 67 over 6, and 7 minus square root of 67 over 6, two critical points. Okay, the next example. So determine the critical points of the following function, q of x. This is, again, we have polynomial function, and when we compute the derivative of this function, here we have composite function and the product of two functions. Yeah. So how to find the derivative of this function? Just firstly find the derivative of the first one using the property of the composite, the product of two functions. Firstly this one, and then this is first function, and this one is second function. So here we have 4 2 minus 8x cubed and times minus 8 because this is composite function here. And the next one is x squared, the second function just, and plus the first function times the derivative of the second function. So here we have 3 x squared minus 9 squared, and the derivative of x squared, it is 2x. So, and now we can simplify and factorize this expression. And if we factorize this expression, this polynomial, we have the next one. So we get this function after factorizing our polynomial. And we need to equaling to 0 to find the critical points. So it will be this equation we have now. And now we have how many equations here? We have 3 equations, correct. So the first equation is 2 minus 8x cubed is 0. This is first one. The next one is x squared minus 9 squared is 0. This is second one. And we have the third one also. So 20x squared minus 3x minus 72 is 0. So this is third equation. And if we solve this, all of them, the 3 equations, what we get? So from the first one, we have 2 minus 8x is 0. This is equal to this one. And we have x is 1 over 4. This is first root, yes. And the second one, so x squared minus 9 is equal to 0. And here we have 2 roots, minus and plus 3. This one is second one. And now the next one, the quadratic equation we have here. Here also discriminant is greater than 0, and it means it has 2 real distinct solutions. And when we solve the quadratic equation, we get the following answer: 3 plus minus square root of 5,769 over 40. You can check this one, and this is third from third equation. And how many critical points we have? We have first one, 1 over 4, then plus 3 and minus 3, and this one, yes, 3 plus square root of 5,769 over 40, and the last one is minus in the middle, yes, so it is 5,769 over 40. So how many? 1, 2, 3, 4, 5. We have 5 critical points of the following given function. The next example, so determine the critical point of the function b of t. So in this case, we have trigonometric function sine squared 3t plus 1. So in this case, again, we need to define critical point. We need to find firstly what derivative of our function. So the derivative of our function is 6 sine 3t times cosine 3t. This one, yeah. So this is a composite function again, and firstly we need to take derivative from this power, and then from sine. And of course we have 3t also, and it will be just 3. So that's why we have 6 here. And derivative of 1 is 0. And now, so recall that critical points are simply where the derivative is 0 or doesn't exist. So now we need to solve our equation: sine 6 sine 3t cosine 3t equals 0. And here we have sine 3t. We can divide these two equations, and sine 3t is 0. This is first one. And the next one is cosine 3t is 0. So we have two equations with sine and with cosine. So we need to solve these trigonometric equations. If we begin with the sine 3t is 0, what we get? We get here when sine is 0, when it is 0, and when it is p plus 2pn. So 2pn, this is period of our sine function. So then we get the following ones. T is 2 over 3 Tn. So this is the solution of the first equation, sine 3t, and the next one, second one. So we have two ones, n is the integer number. And now we need to solve the second one, cosine. Cosine 3t, and when cosine is 0, when it is p over 2 and 3p over 2. So let's put it to our equation, 3t p over 2 plus 2pn. Of course, again, we need to add our period of function 2pn, and the next one is 3p over 2 plus 2 pi n. So we have the next answers. T is pi over 6 plus 2 over 3 pi n, this one, and the second one, pi over 2 plus 2 over 3 pi n. We need to divide by 3 here and here also. N is integer number. So how many critical points we have? We have, so if we consider our periods also, so it is infinite many critical points because of our they have period, and the first one it is 2 over 3 pi n. The next one is 1 over 3 pi plus 2 over 3 pi n. The next one is pi over 6 plus 2 over 3 pi n, and the last one pi over 2 plus 2 over 3 pi n. But it doesn't mean that we have just 4 critical points. It's not correct. We don't have 4. We have more. So in fact, many critical points. So because here we have n is integer number, and for example, if n is 0, here we have 0. Here we have 1 over 3 pi. Here we have pi over 6, and here we have pi over 2. So we have 4 ones. And when pi is n is 1, we have the next 4. When n is minus 1, we have the next 4 again. So, and similarly, we can find other ones also. So they are critical points of our given function b of t. The next one, determine the critical points of f of x. It is 5x e the power of 9 minus 2x. So in this case, again, we need to define our critical points, uh, beginning from finding from derivative of our function. And if you complete our derivative of our function, we have the next one. So it is 5x. So this is product of two functions here, multiplication, of course. We have, and when we compute the derivative, we have 5 e 9 minus 2x plus 5x and minus 2 e the power of 9 minus 2x. So when we factorize it, we get the following. So now this exponential function are never 0. This is not equal to 0. This exponential function, I mean this one, this is never 0. And so the derivative will only be 0 if the next 1 minus 2x is 0. So hence we have x is 1 over 2. And it means we have only one single critical point x half. And the next section of our lesson is minimum and maximum values of function. I think with critical points is all of them are clear. And we have the next section, minimum and maximum values of function. So let's begin again with definition of minimum and maximum uh, values. So we said that f of x has an absolute or global maximum at x is c if f of x is less than or equal f of c. Wherever x in the domain we are working on. Now, we say that f of x has a relative, here absolute or global. F of x has relative or local maximum at x is c if f of x is less than or equal to f of c for every x in some open interval around x is c. Look here, we have difference between these two definitions. So in first sentence we define the absolute or global maximum. So here the our for every x in the domain. And in the second case, we define relative or local maximum. So for every x in some open interval around the point C. So there's difference between them, domain and the open interval around C. Similarly, we can define absolute minimum or absolute or relative minimum. So absolute or global minimum at point C, it is f of x is greater than or equal f of c for every x in the domain we are working on. And we said that f of x has relative or local minimum x of c if f of x is greater than or equal f of c for every x in some open interval around the point c. So we have two types of maximum and minimum points. It is absolute or relative, or we can say instead of absolute global and instead of relative local, global local or absolute and relative. So also we will collectively call the minimum and maximum points of a function the extrema of the function. So relative extrema will refer to the relative minimums and maximum, while absolute extrema refer to the absolute minimums and the absolute maximum. So this is the definition of maximum and the minimum values of the function. So we can see here in our graph what we mean the relative minimum, relative maximum, or absolute minimum and absolute maximum. So we can see here the absolute minimum is this point, this one, because it is least point in our domain. This is absolute minimum. And the absolute maximum, we can consider this point, absolute minimum. And at the same time, it will be relative maximum also. But if it comes the point of D, and here we have relative maximum in this point also, because this is also relative maximum in some open interval of the point B. If it considers like this point B as point of uh, relative maximum, so you can say this point is a relative maximum point, and the relative minimum, this one. So this is locally, and this one are globally. These ones are global. So now, below is the graph of some function f of x. Identify all of the relative extrema and the absolute extrema of the function. So here we can see that this one is absolute. This is absolute minimum of this point because this is the least point of in whole domain of this function. So this is absolute minimum. And this point is the coordinate of this point is 2 and minus 6. This is absolute minimum. Absolute minimum of this point. So now we can see the absolute maximum is in this point. So it is 4 and 5. This is absolute maximum, 4 and 5. So we have also relative minimum and relative maximums. So the relative minimum is in this point. This is relative minimum, and it is, and this one is also relative minimum. So absolute minimum will be relative minimum also, and here we have minus 3 and minus 2, and 2 and minus 6. And now we have relative maximums also. So the relative maximums are this point, and of course the absolute maximum point also. So we have minus 1 and 2, and 4 and 5. So we have following extrema points. Extrema points. Okay. Let me clear. So the next example, identify the absolute extrema and relative extrema for the following function. F of x is x squared on minus 1 and 2. Look the graph of our function. So x squared, this is parabola, but we need to take the parabola on the interval minus 1 and 2. So here we have the graph of our function on the interval minus 1 and 2. So what will be the here relative maximum or relative minima? So it looks like we have got a relative and absolute minimum of the 0 at x0 in this point, and an absolute maximum of 4 at x is 2. So here, yeah, if x as 2 is 2, it is absolute maximum for this function. And note that x is minus 1 is not a relative maximum since it's at the end point of the interval. So this is not a relative maximum because it should be in the open interval of this point. In our case, this is end point. That's why we cannot call this point as relative maximum point. So this function doesn't have any relative maximums, but the absolute maximum is at the point x2, 2, 4, it is relative maximum, and I mean absolute maximum, sorry, absolute maximum, and relative minimum is 0, 0. This is relative minimum. This one is absolute maximum. Absolute maximum and relative minimum. Okay. Now, let's consider the next one. Identify the absolute extrema and relative extrema for the following function. So this is x cubed on the interval minus 2 and 2. So we have the following graph of our function, hyperbola we call it, and this function has an absolute maximum of 8 at x is 2. This is absolute maximum point. 2 and 8. This is absolute maximum point. And we have absolute minimum point also. This point, yeah? So it is minus 2 and minus 8. This is absolute minimum point. Absolute minimum point. This is absolute minimum point. And but this function has no relative extrema. We cannot say we have relative extrema in our function. We have just absolute maximum, 0.28, and absolute minimum, minus 2 and minus 8. Okay, so the next function, identify the absolute extrema and relative extrema for the following function. So f of x is cosine x. So this is this is graph of this cosine x. So this is periodic function, and the cosine has extrema, relative, and the absolute that occur at many points because we have, again, I repeat, we have period of this function 2 pi. So cosine has both relative and absolute maximums of 1 at minus, here in our case it is minus 4p, for example. Here we have, yeah, minus 4p. Minus 4p, minus 2 pi, 0, 2 pi, and 4 pi, etc. So they are absolute maximums of 1 at this point, and the cosine function also has both relative and absolute minimums of minus 1 and minus 3 pi, minus pi here we can see, yeah. So, or pi and or 3 pi. So at this point, we have both relative and absolute minimums of minus 1. So again, cosine has both relative and absolute maximums of 1 at this point. It is we have infinite point, and the function has both relative and absolute minimums of minus 1 at this point. This one and this one. Okay, now we have the following theorem, Perma theorems. If f of x has a relative extrema at the point C, and the derivative of f at the point C exists, then the point C is a critical point of f of x. In fact, it will be a critical point such that the following equation is held. So f derivative of f at the point C is 0. So one more time, we can repeat. So f of x, if f of x has relative extrema at the point x is C, and the derivative of in this point exists, then our point C is the critical point of a given function. If it is critical point, it means the derivative of this function in this point equals to 0. So this theorem tells us that there are a nice relationship between relative extrema and critical points. So in fact, it will allow us to get a list of all possible relative extrema. Since a relative extrema must be a critical point, the list of all critical points will give us a list of all possible relative extrema. So we can find from the list of relative extrema points, critical points. And consider the case f of x is x squared. We saw that this function had a relative minimum at x0. So According to Fermat theorem, x0 should be a critical point. If it is relative extrema, it will be critical point. So derivative of the function is 2x, and equating to 0, this one we get x is 0 is a critical point. But be careful not to misuse this theorem. So it doesn't say inversely that a critical point will be a relative extrema point. This is not correct. So if we have critical point, it will be relative extrema. It's not correct. But if it is relative extrema, it will be critical point. So to check this one, consider the following example. F of x is x cubed, and here f derivative of x is 3x squared. So if you equate to 0 to find the critical point, x is 0. It is critical points of this function, but it's not a relative uh, extrema of our function. We consider it this example. So it's not the relative extrema for x cubed, but this is critical point. So I think it's clear this with this theorem. And now let's continue our lesson. So, and the next section is finding absolute extrema. So, finding absolute extrema of f of x on the interval AB. So, what should we do? Let's consider these steps. The first step is verify that the function is continuous on the interval AB. Second one, next one, find all critical points of f of x that are in the interval AB. This makes sense if you think about it. Since we are only interested in what the function is doing in this interval, we don't care about critical points that fall outside the interval. So we need to find all critical points in the interval AB, only in this interval, on the given interval. And the next step, evaluate the function at the critical points found in step 1, the previous step, and the end points. So we need to evaluate the function at these points. And the last step, identify the absolute extrema. Now we will consider some examples how it's working with functions. For example, determine the absolute extrema for the following function and the interval. So we have the following function g of t, and we have the following interval -4 and 2. So firstly, what should we do? This is continuous function. This is continuous function. This is polynomial function. That's why it's continuous. And now find the derivative to define the critical points of this function. So derivative of g is this one, and we can factorize, and we have 6t plus 2 times t minus 1. So if we equate to 0, this one, we get 2 critical points, -2 and 1. And let's check. -2 belongs to our interval. Yes, and 1 is also belongs to our interval. So we need to find now we need to evaluate our function at the critical points and endpoint. Endpoints here -4 and 2. So let's put instead of t minus 2 and g minus 2 is 24. If we evaluate, and g minus 4 will be -28. And this is -4. This is for the endpoint. And the second critical point, g of 1, it is -3. Here we need to put, do not confuse with derivative of this function. We need to put to the given function. So g of 1 is minus 3, and g of 2 it is this second endpoint. Yes, this is 8. You can check this point. And now let's define the absolute extrema. So we need to find absolute extrema is the largest and smallest values from this list. So the smallest one is minus 28 and the largest one is 24. So these two ones. Yeah, we have so 24 and 20 minus 28. So uh, this is absolute maximum 24, absolute maximum, and this one minus 28, which occurs at t is minus 4, it is absolute minimum. This is absolute minimum. So we need to define the largest and the smallest one from our list. Okay, now the next one. Determine in the absolute extrema for the following function. F of x is 8x cubed plus 81x squared minus 42x minus 8 on the interval minus 8, 2. So again, we need to find the critical points of this function. So firstly, to find the critical points, take the derivative of this function, and it will be 24x squared plus 162x minus 42. And if you factorize the following polynomial, we get this. So, and equating to 0, we can find the critical points of the following function, and it is minus 7 and 1 over 4. We have two critical points. And let's check, are they included to our interval or not? Yeah, both of them are included to our interval, so we can put these values to our function. So let's evaluate our function. So f minus 8 at the critical points and the end points of this interval. So let it begin with the list 1 minus 8. So if we put minus 8 here, here we need to put, yeah. So it is 1416. This is for minus 8. And for minus 7, this is critical point of our function. It will be 1511. So this is for minus 7. And the next one for 1 over 4. So it is, if evaluate for 1 over 4, if we put here, you can check it, it will be minus 30.3125. So we get this one, and if we evaluate for the last this point, this is endpoint of our interval. So we get the 296. So we have four values, uh, two critical points and two endpoints. If one of critical points doesn't belong to our interval, we didn't take this. We don't take this. But in our case, the two of them are belongs to our interval. So now define what is absolute maximum and absolute minimum. So absolute maximum we can see here this one. So the absolute maximum is 105,011. This is absolute because this is greatest value. So, and the least value is this one. Yes, minus 30.31 and 25. So they are absolute minimum, maximum, and absolute minimum of given function. Given function. Okay, now let's consider the next example. Determine the absolute extreme of the function f of z. So here we have fractional function on the interval minus 10 and 0. Again, we need to find critical points. So if we find the critical points with using the derivative of this function, so we have the following equation when we compute the derivative of our function. And if we solve this equation, we have the following critical points. So now, but in our case, the second one is 0.2426 approximately, of course, here. So it's not belongs to our interval minus 10, 0. This is not belongs to minus 10 and 0. So that's why we just take only this one to evaluate our function. So, and two endpoints. So we have f minus 10, f minus this critical point, and f0. And when we identify our absolute minimum and absolute maximum, here the least value is this one over 2. I mean, the greatest value is 1 over 2. This is absolute maximum, and least value is this one. We need to numerical uh, value of this function, this point. So that's why we can take approximately value this point. So it is least value. So this is absolute minimum. Here we can see, and we have absolute maximum. It is 1 over 2. And the next example, determine the absolute value extrema of f of y. Here we have the trigonometric function sine y over 3 and plus 2y over 9 on the interval minus 10 and 15. So again, we need to find first the critical points. To find critical points, one more time, take the derivative of this function and solve according to 0. The derivative of this function, solve the equation. So here we have this kind of equation, and when we solve it, we have this one, and we can find the approximately value of this function. It will be 2 point. So y over 3, it is equals to 2.3005. So this is all of them are approximately values. Why we need to find these values? Because we need to identify is it belongs to our interval or not, and then when we evaluate our function, we need to numerical values of these points. So we have uh, many critical points. We have such kind of critical points. This ones. In our case, it is this two ones, but here we have n is integer number, and now we need to consider only on the interval minus 10 and 15. That's why the critical points belong to this interval will be these three ones only. And then we need to evaluate our function for these critical points and endpoints of our interval minus 10 and 15. So we have the following values, and when we identify the largest and least and the largest one, we have absolute maximum is this point, this one, and absolute minimum is this one. And pay attention when we write absolute maximum and absolute minimum, we need to write the argument. So x and y2, I mean there's two coordinates of this point. And the next one, I think it's also not difficult for you now. So we have the exponential function on the interval minus 1 over 2, 5 over 2. So when we find the derivative of this function, we have the following one. So, and if we after factorizing, of course, and this is not equal to zero. I mean, the exponential function is not equal to zero always, and that's why just find the values which is equal to zero to this polynomial function. So we have -1 and 7 over third, but -1 is not belongs to our interval because this is our interval is from -1 over 2 till 5 over 2, but 7 over 3 is belongs to our interval, so it will be only critical point of our function. And now again evaluate our function on this critical point 7 over third and end points of our interval, and we have these three values. So and when we identify which is greater and which is this one, so the absolute maximum is e 23 over 8 at -1 over 2, and the absolute minimum, this one, is my e the power of -392 over 27 at the point v is 7 over 7. This is in critical point. This is the value we get. So I think it's clear. So how to find the critical points and uh, and extrema points of the given function using the derivative of the function. The next time we will continue study the application of derivative to the functions, finding um, so uh, increasing and decreasing intervals, monotonicity, and the starting the functions. If you have any questions, you can contact in our discussion group. Thank you for your attention.